Okay, guys, in this lesson, we're going to talk about relations and functions and how to identify if a relation is a function or not. So first of all, anything can be a relation. So that's the first thing that we need to know. Anything can be a relation. So it's simply a set of input and output values represented in an ordered pair. We will also see that we can represent these in a few different ways, but the most basic idea is that we have groups of information and we have ordered pairs. It is a relationship between sets of information such as hair color and student's name. So if I were to take a survey of your hair color and then I'd put your name, this is just a relation. We have two pieces of information. Or if I took a survey and asked your age and what your shoe size was, that would be information. But a relation, again, is our broad topic, and there is no special rule that applies to a relation. So again, relations can be represented as information as ordered pairs, as a graph, as a table, or in our last representation, a mapping. However, when we do have a special rule applied to relation, we have a function. So a function is more specific. It is a type of relation and it has a special rule, such as this equation here, y equals 2x plus 1. So when we have a function and we have that specific rule, it allows for only one relationship between each input value. So we need to make sure that we write this definition in our notebook. So a function is a set of ordered pairs, which can also be displayed in a graph or a mapping, where each input value, each x element, each input value has only one y element associated with it. Each input value, which are your x values in the order pair, each of these has only one output value. So our broad topic is relations. So everything can be a relation. We compare any pieces of information together to create a relation, but we're going to take a look and learn to determine if a relation is a function or not, if it has a special rule or not. So I like to think of a function as like a vending machine. You have your different codes to get your items. So our code is our input, and then the items that we get out once we push a specific code gives us the desired item. So if I selected this first item, which is a cheddar and turkey snack, and I wanted this, I would input A1 and I would get out this item. If I were to put A1 and I got out the Gatorade, then this would not be a function because A1 in our situation only gives us this item. But if it gave us this item or this item, then it's not a function. It has to be predictable. Every time I press A1, that's my input, A1 gives out one specific item and I know what that item is. So if I pressed A1 and I got the Gatorade, which is C1, then this vending machine would not be a function. It would not give out what I anticipated, which is this item here. So two new vocabulary words are domain and range. So your input is also called the domain. Your output is also called the range. So just know that output and range are interchangeable and input and domain are interchangeable. So in this example, our domain would be the codes like A1 or A2 or A3. The range or the output would be the actual items that come out of our machine. So a function is a relation where each input produces one unique output. Functions are predictable. So let's write this in our notes. Functions are relations that are predictable. Each input, such as A1, gives out the output. So in this situation, it is saying that A1 is water. If I press A1 and I get water, and then I press A1 again and I get Coke, A1 gave me water and it also gave me Coke, and it's not predictable. It's not giving me one unique output. It has to give me the exact same thing every time I press the code A1. And so this vending machine, if it is functioning properly, is an example of a function because every time I press A1, I get water. If I come back the next day and press A1, I'm going to get water again. If I press A3, if I put in A3, I'm going to get a Pepsi. It gives me one unique output. If I press A3, it's not going to give me chips, it's going to give me Pepsi. B1 gives me chips. So our domain in this situation, like we just said, is all of our codes, and our range, our output, is all of the products. Here is a list of some interchangeable words and phrases that all mean the same thing. So our domain is a set of all the first elements of our ordered pairs. So if we had 3, 7, the 3 is our input value. It's the domain. The range is the output values. It is the second element. So in this example, 7 would be the range. It is the y coordinate. They are also the dependent values. So my products such as Sprite, I get Sprite depending on which code I use. So let's take a look at graphs, and we're going to talk about what's called the vertical line test. The vertical line test allows us to know if a graph is a function or not. The vertical line test says if I draw a vertical line anywhere on the graph and I intersect more than one point, it is not a function. So this vertical line intersected at 2 different points, so this whole graph is not a function. This ordered pair is -4, 2, and this ordered pair is -4, 9. To be a function, each input value, each x value, can only have one unique output. But this -4 has an output of 9 and an output of 2. So it doesn't pass the vertical line test. It doesn't meet the definition of a function. It is not a function. In our second example, no matter where I draw a vertical line, I am not going to intercept more than one point. So this is a function. Each x value, if I were to write out all these ordered pairs, each x value would go to one unique output value. And here we have this line going through the origin, sloping in a positive direction. And if I draw a vertical line wherever on the graph, I'm only intersecting at one point. It passes the vertical line test. This is a function. Here in this example, we have the vertical line itself, and if we were to draw a vertical line, that's not a very good vertical line, but if we were to draw it, we can see it intercepts more than one point. It intercepts at every single point. So this is not a function. So the vertical line does not pass its own test. It is not a function. Now here we have a horizontal parabola, and if I draw a vertical line, we can easily tell that it intercepts at more than one point. So this is not a function. This example, we have the horizontal line. If we draw a vertical line anywhere on the graph, it only intercepts at one point. So this is a function. Now let's take a look at tables and mappings. So remember, the whole idea is to see if each input value has only one output. So when I'm given a table, I'm looking at just the x's. None of these x's repeat, so they will only give off one output. And it's okay that they all have the same output. That's totally fine. But if your x's, since they do not repeat, I don't have like another -3 going to like 7. Okay, I don't have that in this situation. So this is a function. This mapping, so these are our input values or the x values, and these are our output values called the y. This 5 is going to -3. This 5 is going to -2. It's also going to -1. So you can see that this input value 5 does not have one unique output. It has many. So this is not a function. Let's take a look at this table. We have -3, we have -2, we have a -1. These are all different. But look, notice I have a -1 here and a -1. So -1 is going to 3, but it's also going to 5. It can't go to two different outputs. This is not a function. It's like putting in A1 and getting Pepsi instead of water, okay? So this is not functional. Let's take a look at a few more tables. Again, all we're looking for at first is the x values, 3, 6, 9, 12. None of these repeat. They all will have their own unique output, so this is a function. Our second example, I'm looking at my x values. I notice I have a 4 and another 4. This 4 is going to 2, and then it also goes to 8. So this is not a function. We can see our input values. We're checking these. They're all different, so they will all have their own unique output. This is a function. And the last example here, I'm looking just at the x values across. I can see that I have a 7 and another 7, and they have different outputs. So this is not a function. Okay, let's look at mappings. So, and let's get a different color. So here we go. We can see that this 2 has two different outputs. I don't even care what those outputs are, but just because I can tell that it has two arrows coming from it, so this automatically makes this mapping not a function. The 2 has an output of 8 and 11. This 4 also has two different outputs. In this example, 5 has one output, 8 has one output, 12 has one output, and 14 has one output. So they all have one unique output, so this is a function. So you're looking to see how many arrows are coming from the input. These all have one output. It's all going to the same output, which is okay. It's kind of like having a vending machine that has all water. It's okay that each code gives you water. Okay, so this is a function. Now let's talk about where we just are given pieces of information. So here's what we have to ask ourselves. So our input, an email address. comma, individual. So our input is the first piece of information. So if I type in an email address, does it have one person on the account? Yes. So if I type in my email address, it goes to me. It doesn't go to anybody else. So it is functional. So this is a function. So what about if you're an individual? Will you only have one email address? Possibly, but could I have two email addresses? Absolutely, and I do. So this is not a function because there is a possibility that an individual has more than one email address. What about, whoops, we forgot the I here, driver. What about a driver having a driver's license? So usually every driver has one driver's license, but what if I move to another state? I could have my Georgia's driver's license, and then let's say I move to Florida, then I would have a Florida. So I could possibly have two different licenses. So I'm going to say not a function. So on these, you just have to kind of think about, is there any possible way that this input could have more than one output? So I could have two different licenses. Okay, a driver's license, if I pick up somebody's driver's license, it only belongs to one driver. It has one unique output. So this is going to be a function. Okay, what about a locker combination? So at school, we assign everybody, give everybody a locker combination, and that combination is unique, and it just goes to one student. So this is a function. Okay, what about at school if I assign a student to one locker, but let's say they also have a gym locker. So a student could have two lockers at school. They could have the one in the hallway, and then they also could have one in the locker room. So we're going to say not a function. So again, you just kind of have to ask yourself, does this input piece of information, is there only one possible output? And so just think of the different situations. And here is just a little summary of what a function is in the left column. So we have functions as ordered pairs, tables, sets of information, mappings, and a graph. Then we have things that are not a function in the same representations. And then I have listed out what makes each of these relations not a function. So remember, everything on this page is a relation, but then we have some relations that are functional and some that are not. To be a function, each input can only have one unique output. And I hope this helps.